All right, this is my review of Chapter 7 exam in preparation for our final. What is the magnitude of the momentum of a 0.2 kilogram baseball traveling at 35 meters per second? The definition of momentum is its mass times its velocity. They wanted the magnitude of that. I have the mass times velocity. That is 8.75 kilogram meters per second. This next question includes the requirement for you to use some previous learned material from actually first semester. We have a 0.18 kilogram baseball dropped from rest. There's my initial velocity. From some height, there's my delta y above ground. We want to know the magnitude, so no direction, because magnitude was requested, just before it hits the ground, if we assume air resistance is negligible. I need to know the velocity of the ball right before it hits the ground. So 5, 4, 3, 2, 1. I know the velocity initial. I know how far it drops. There's my delta y, which is a -3 meters because I went downward. And I know the acceleration is -9.8 meters per second squared. I can go find my equation sheet, and I got to find the final velocity of that ball right before it hits the ground. I know its initial velocity, I know its acceleration, I know its delta y. So I'm going to use the equation that doesn't have time in it. And so I'm going to find the final velocity is squared is equal to the initial velocity squared plus 2 times a times delta y, and rearrange that equation for final velocity and solve for that final velocity. Now that final velocity is going to be negative, if we assume down is negative. And so I can then find the momentum of the ball right before it hits the ground, because I know its mass is 0.18 and its velocity is 7.67 meters per second downward. So its momentum is 1.38 kilogram meters per second downward. It wanted to know the magnitude, didn't ask for direction, which is why there is no negative sign in my answer. I have 3 objects moving along in a straight line as shown in the figure, taking positive to the right, and that means to the left is negative. They want to know the total momentum of the system. Well, what is the total momentum of the system? It's the momentum of 1 plus momentum of 2 plus momentum of 3. So I'm going to calculate that, and they didn't give me the signs. So I have to go and plug in the signs, because to the left is positive or negative and to the right is negative. This is to the right is positive, to the left is negative. So you got to pay attention to make sure you have the sign. So this is object 1, 2, and 3. Object 2 has a negative momentum. So I multiply the mass times its velocity, multiply the mass times its velocity, which is -4, multiply the mass times its velocity, add all that up, and the momentum, they didn't ask for magnitude, is -14 kilogram meters per second, or 14 kilogram meters per second to the left. Number 4, 2 air carts moving along an air track towards each other. Cart A has a mass of 0.53 kilograms, moves to the right with a speed of 0.75 meters per second. Cart B has a mass of 0.36 kilograms, moves to the left with a speed of 1.28 meters per second. Once again, wants to know the total momentum of the 2 cart system. Didn't ask for magnitude, which means I better be paying attention to the signs. So I have a picture. This is to the right. I have a mass. This is to the left, which is why I put a negative sign in front of that velocity. Momentum total, momentum of 1 plus the momentum of the other. I do believe that people left off the sign -1.28 in this problem, which is a very common mistake. So please pay attention. Momentum has direction. Add them, multiply and add, and I'm going to have a negative total momentum. In other words, the system's total momentum is 0.063 kilogram meters per second to the left, if we assume to the left is negative. All right, similar problem here, people not paying attention to the negative signs. I have a ball that has a mass of 0.1. It strikes, it's originally traveling at 15 meters per second. It strikes a wall, rebounds at 13 meters per second. Want to know the change in momentum. definition of change in momentum is momentum final minus momentum initial. Draw a picture. Draw the initial velocity. I assumed it was moving to the right. I don't care which direction you start off with, because if you pay attention to the signs, you will get it correct. Here's my wall in blue. It bounced and went backwards. So it has to have a different sign in velocity. So it's negative. Change, final minus initial. The final momentum is its mass times its final velocity. Notice there's a negative sign in there. Minus the initial, which is its mass times a positive velocity. You'll find the change in momentum to be negative 2.8 kilogram meters per second. There is a negative sign. Try drawing it the other way and going to the left and bouncing, changing to the right. You will still get negative 2.8. Calculate the impulse. Impulse is the force times time. Let's go take a look at our equation sheet. This is impulse. Notice we're in momentum and collisions. Impulse, force times time equals change in momentum. Here we are. Okay, I want to know the impulse that has for a force that lasts 4.5 newtons, it lasts for 1.4 seconds. I know the force, I know the time. I multiply the two together, that gives me 6.3 kilogram meters per second. That is also okay to give me Newton second, but those seconds squared and the Newton will cancel with one of those seconds and give me units of momentum, because that is what impulse is, change in momentum. The next one involves the same kind of concept. I have a golf ball of a certain mass that starts at rest. Notice it has an initial velocity of 0. It is struck with a club and then has a velocity of 89 meters per second. If the club was in contact with the ball for 0.75 milliseconds, which I converted for you, did I do that right? Yes, 3 times, yeah. What is the average force exerted on the ball by the club? Well, force times time equals the change in momentum. I'm looking for the force. I know the change in momentum. I have the final velocity. I know the initial velocity. Change in momentum is final minus initial. I'm going to rearrange that equation for force. So change in momentum over time. Change in momentum equals final minus initial over time. Initial was 0, it started at 0. So I end up with just the final momentum, which is its mass times that final velocity over time. And then I can find that to be 5,933 newtons. A 2 kilogram mass moves at 6 meters per second, collides head on with a 1 kilogram mass at rest. If the collision is perfectly inelastic, which means it sticks, what is the speed of the masses just after they collide? There's no, in all my collisions, we have conservation of momentum, which means the momentum initial has to equal the momentum final. Draw a picture. I have an object 1 traveling to the right. I have an object 2 that's at rest. Here is what they look like afterwards. They're one object with a total mass of the 2 masses added. What's the momentum initial of the system? Well, it's just the momentum of object 1, which is its mass times its velocity. And that must equal my final momentum. Notice 2 plus 1, those are the 2 masses added together, times the final velocity. I want the final velocity, that's what they're asking for. So rearrange that equation for final velocity, and you will find that to be 4 meters per second. Okay, 4 meters per second. 2 ice skaters. This is an example of an explosion, so the opposite of that type of collision. They are standing at rest. Their initial velocity is 0. I know the mass of 1. I don't know the mass of 2, but I know both of their speeds after they push each other off. They're on ice because there's no friction, which means momentum is conserved. They have asked us to solve for the mass of object 2. So initial momentum of the system, which is 0, they all started at rest, has to equal the final momentum of the system. Well, take a look at the final momentum. Object 2 is moving to the right, so has a positive velocity. Here's my mass times object 2's velocity. Has to equal object 1's momentum. Well, it's its mass times its velocity, so there that is. We don't know mass 2, so we got to solve for it. I'm going to rearrange that equation by getting rid of the green and subtracting it from both sides of the equation, which I did. Then I have to get rid of velocity 2 final, which I know because I'm solving for mass 2, and then I will plug in my values. And notice I get a positive number, which is great because mass is always positive, of 36.4 kilograms. This last one is a challenging problem, and it was kind of an extra credit, but I'll go over it quickly. I have a block of mass 10 kilograms with some speed. I have another block with 67 kilograms and also have a speed of 0.5. They collide and they stick, and we are told that they have a final velocity of 0.9, and we wanted to know how much kinetic energy is lost. In order to find the amount of kinetic energy lost, I have to figure out the kinetic energy initial and kinetic energy final of the system. I can't find the kinetic energy initial until I know that velocity of mass 1. I will find velocity of mass 1 using conservation of momentum. Initial has to equal final. I have 2 objects moving in initially, so I got those 2 momentums added together. That's the total momentum of the system. I have 1 object that's stuck together, so the masses are added, and I have some final velocity, which I know. I rearrange that equation and solve for the initial velocity of object 1. I will then solve for it and found that the velocity of object 1 is 3.58 meters per second. Now that I know that, I can calculate the initial kinetic energy of the system. Kinetic energy of object 1 plus kinetic energy of object 2 before the collision. So plug in the equation using the equation, kinetic energy equals 1/2 mv squared. Do so for each object, add it together. The initial kinetic energy was 72.37 joules. The kinetic energy final of the system is the mass of the 2 objects added together, 10 plus 67, times its velocity squared, times 1/2, 31.2 joules. They wanted to know how much was lost. Notice it went down. 72 minus 31, 41.3. That is the answer.